All right, so we had those practice problems. So if you didn't get those answers, that 2.97 meters per second, the 0.0565 meters, or the 1.85 meters per second, here's some hints to help you out. So on that first one, again, we notice it's going from point 1 up here to point 2 down here. So we're going to be using that work in plus work done by friction equals, we're using the big work kinetic energy theorem equation, which narrows us down to 0 equals K2 minus UG1. So this solves pretty darn similar to the problem we had with the girl on the swing set, that we get V is equal to the square root of 2GH, but we do have to find the height here. And so we find that height by doing a little trigonometry, because they tell us the ramp length is 0.75 meters. So we have to go ahead and use that to go ahead and find that height. All right, for our second one, we do have to convert centimeters to meters, so make sure you do those conversions. Here's an example of how you would convert that spring constant from newtons per centimeter into newtons per meter. Because it is going from one point to another point, we're going to go ahead and use the work kinetic energy theorem. And when we use that, it narrows down to just the final potential elastic energy minus the initial. Do your algebra, and you should come out with 0.0565 meters. There are some shortcuts to calculating that one, but I would stick with just kind of doing all the steps. This one over here, again, make sure you change those centimeters to meters on that one. It's going from one point to another. The difference is here, my final point is not compressing the other spring. My final point is just out in the open. They're skidding across that frictionless surface. So I have K2 minus UEL1. Plug in your numbers, you should get 1.85 meters per second for that one.